All right, so towards the latter half of the class, we're going to focus more on understanding the relationship between variables, specifically in the context of hypotheses and statistical testing. However, one additional calculation I want to talk about in terms of bivariate statistics more generally, that kind of builds from what we've been talking about with correlation coefficients, is linear regression. So correlation coefficient, super common bivariate analysis that's used to assess and understand the relationships between two variables. Linear regression takes it one step further and uses the relationship, similar to those trend lines we were looking at, uses those trend lines to predict what's going to happen in the future, not just what is happening now within this data set, but how can we use the values that we have in order to predict what we would expect if assuming that these values continue the way that they have thus far. So, for example, if we look back at this chart that we saw earlier with correlation coefficients, where we were comparing math rating to stats class rating. So, stats class rating, the question all of you were asked in your first application assignment: how do you feel about taking the statistics course on a scale of 1 to 10, 1 being panicked, 10 being stoked, compared to how do you feel about math, 1 being I hate it, 10 being I love it. So this is a chart that's looking at the relationship between those two variables. We see this trend line going up in the middle. Essentially, linear regression is used in a linear situation like this, where we're not looking at those curvilinear relationships. We're looking at linear relationships where we can extend the trend line outwards. So we'll come back and we'll come back to this in just a moment, but that's essentially what linear regression is doing, is it's taking the data set that we have available to us and it's using that to predict, okay, what would happen in the future? What would happen in the cases that we don't have? So it's sort of moving into inferential statistics, essentially. It's using a data set to make some sort of additional predictions. Okay, so here's how your book talks about these variables. So your book talks about this linear regression line comparing college GPA to high school GPA. Okay, so let's see what we're looking at on a more detailed level here. So we have this regression line in the middle. It's showing the relationship between these two variables, variable y versus variable x. So essentially, we're linking in the concepts here of our dependent and independent variables. So the variable y is the dependent variable x is the independent variable. Just with regression analysis, it talks about these two terms in a slightly different way. It's essentially the same concept though. So we're gonna walk this out. We're gonna look at a couple examples of how this is applied. I want to explain some of the context that's presented in the textbook visually first, just to make sure folks are familiar with what's happening here. And then we will look at some actual real world examples of professional journal articles that share the results of linear regression. Okay, so essentially what linear regression is doing is it's using one variable to predict the other. So it's calculating the amount that the dependent variable, in this case, college GPA, it's calculating the amount that that variable changes in response to a 1 unit increase in the x variable and the independent variable. So how does an increase, so if we're thinking about variables as a positive relationship, when one increases, the other increases, how specifically, linear regression tells us how specifically does one variable increasing influence the other variable. So if one variable increases, if the independent variable increases by 1 unit, then what does it do to the dependent variable? Does the dependent variable increase also by 1 unit? Does it increase by less than that? Does it decrease? What happens here? So in this example, we're looking at the relationship between college GPA and high school GPA. Again, independent versus dependent variable. The dependent variable is going to be college GPA. That's going to be dependent upon high school GPA, at least in a way, right? Again, with statistics, it's all about hypotheses and predictions and making our best guesses. So this doesn't mean that just because somebody had a poor high school GPA, that their college GPA is absolutely also going to be poor. We're just using this data set to make predictions, to make assumptions, to somehow use numbers to try and understand what we would expect to see happen. Okay, so let's visualize this. Here's our little reminder about dependent and independent variables down here too. So the amount that it calculates, so the linear regression model can be used in a lot of ways, but one of the things that it does is it tells us the amount that we would expect that independent variable to influence the dependent variable. So it calculates the amount that we would expect the dependent variable to increase. That's what's known as this little b, this italicized b, or what's called beta. Sometimes we see it reflected in different ways. Sometimes it's a capital B, sometimes it's this fancy looking B here, sometimes it's a little b. Everybody does it a little bit differently, which is not a helpful way to report statistics, but is a reality of statistics. Just like when we were talking about correlation coefficients, there's a lot of different specific statistical calculations that can be used to calculate a correlation coefficient. We're focusing on the most common one, which is Pearson's R, but there are other options. Same with linear regression. It can be used in a whole lot of different ways. There's ways to calculate regression for nonlinear relationships, like those curvilinear relationships we were looking at. That's a different kind of regression. There's multilinear regression if we're working with more than two variables. So this gets a lot more complicated depending on how much we want to understand. With linear regression, one of the most important things linear regression can show us is, again, how does 1 unit of an increase in the independent variable influence the dependent variable? And that's what this b or beta, that's what the slope is essentially calculating. So let's visualize how this looks for a 1 unit increase in high school GPA. So here we see high school GPA increasing from 1.5 to 2.5. So it's a 1 unit increase in high school GPA. We saw college GPA increase by 0.704 units, essentially. So we saw college GPA increase from right here about 1.75 to about 2.5. So we saw a 1 unit increase in high school GPA results in a 0.704 increase in college GPA. All right, so this is essentially what linear regression is showing us. How much is that X variable, or how much is that Y variable going to change as a result of the independent variable? How much is the dependent variable going to change as a result of the change in the independent variable? I'm just repeating it a lot of times so it can start to sink in. This is essentially what it's showing us. When we look at how this information is actually presented in research articles, we don't get this level of detail, however. So again, with your book, we're only reading part of this chapter. We're scratching the surface. I'm going to throw up some complicated tables that are going to feel confusing at first, but we're going to stick with it. But first, again, we want to think about linear regression because there are some flaws with linear regression. So for example, the other example we used in the previous video was looking at math rating and stats class rating. When I'm using this kind of forecast, this like linear regression forecast function in Excel, and it's telling me, here's how we would expect the data to continue flowing, what's wrong with this? Like, what doesn't make sense about this image that we're looking at here? Can you identify the flaw? This is beyond our scale, right? So we had a scale of 1 to 10 for stats class rating and math rating, and the prediction is showing us that these scores are going to be 11 and 12, maybe eventually 13, and that doesn't quite fit with the variables that we're working with. So with linear regression, we can use it in some situations. In some ways, it can be really helpful. Again, we have to think about, does this actually make sense, though? And I wish I could tell you that all of the published journal articles that use linear regression have thought about this and aren't going to be sharing results that don't make sense or that confuse the findings. Like if we tried to publish an article about this and use linear regression, it wouldn't make sense because we're working with a much smaller range. However, linear regression is still a tool that can be used in some situations when it is informed by theory, when it makes sense with the variables that we're working with, as a way of making these kinds of predictions. So my point here is just to know that linear regression is a very narrow lens. It can be useful in very narrow situations of data that we're working with, but it is likely something that you'll see when you're reading journal articles. You'll see maybe not linear regression, but you'll see some sort of form of regression. What regression is doing, again, is it's using data to make predictions about how does one variable influence the other. Okay, so here we are back to the study of police officers, spouse and partners, looking at secondary trauma, relationship violence within secondary or within those relationships. And here is an example of the type of table we're going to see sharing results of linear regression. So let's start to break this apart. We're not going to look at every aspect of this table. We're going to focus in on just one thing, which is very commonly what I'll have you do when we're starting to get into interpreting the results of existing data sets. We'll look at one specific aspect of the table, so we're not going to be expected to understand everything. Similar comment here, ignore the stuff that you don't know for now. Let's look for the stuff that we do know. So first thing to do is always to read the description of the table. We can see that this is a linear regression model predicting S/P secondary trauma at 12 months. So it's telling us what it's predicting right here, spouse and partner secondary trauma at 12 months. Let's get a reminder here. Regression is calculating how much a 1-unit increase in the independent variable is influencing the dependent variable. So here's our reminder of what we're looking at. So the first thing we want to figure out is what is our independent variable, what is our X variable, and what is our dependent variable, what is our Y variable. We know that we're predicting spouse/partner secondary trauma. So is that the independent variable or is that the dependent variable? So hopefully we're realizing if we're predicting secondary trauma, the secondary trauma is our dependent variable. The secondary trauma is the thing that's being influenced. We're looking at how do all these other predictors, how do all these other variables influence spouse and partner secondary trauma at 12 months. So this is one of those situations where it might be a little bit fuzzy to think about at first, but if we stop and slow down and think logically, what's being predicted here, what is being influenced versus what is doing the influencing, it can help us figure out what's happening. So our Y variable, our dependent variable, is going to be spouse and partner secondary trauma. That's the thing that's being influenced. We're going to focus on just one of the possible influencers, or predictors as they call them here. We're going to focus just on this last one here. So we're not going to look at the other variables in this table, although we could if we wanted to understand their relationship with spouse and partner secondary trauma. So the X variable, the independent variable that we're going to be looking at, the independent variable doing the influencing, is officer PTSD symptoms as reported by their spouse and partner. So again, we want to read the study a little bit more in depth if we wanted to understand specifically how were these predictors calculated, which if we were doing some sort of intense research study, we'd want to know those kinds of details. Right now, we just know officer PTSD symptoms, spouse and partner report. This is some sort of measure that is spouses and partners are reporting to the researchers, here are the symptoms that my spouse or partner, the officer, here are the symptoms that the officer is experiencing of PTSD. So spouse or partner is reporting on behalf of their spouse, partner, the officer. All right, so the overall variable, we do want to have a little bit of an understanding of. The overall variable that's being predicted is this modified secondary traumatic stress questionnaire. I just included this little snippet from the study in case we want to read about it. If you skim through it, you'll see that there's 20 items, 18 were used in this study, total score ranging from 18 to 90. So whatever this particular measure was, so this is an example of a construct. So secondary traumatic stress, so the partner's secondary traumatic stress, which is what's being predicted here, this is a construct. The construct was developed through this assessment tool. So here we are remembering a few weeks back. We're remembering the ways that data are collected. One of the ways data are collected are with assessment tools, which are kind of like fancy surveys that are designed to get at one construct. So if we're measuring the construct of well-being, for example, we're going to want to ask about different dimensions of our physical, our spiritual, our emotional, our mental well-being. With this situation with secondary trauma, they use this modified secondary trauma stress questionnaire in a very similar way to get at all the possible dimensions or ways that secondary trauma can show up. So this is how they have conceptualized and operationalized this particular variable, secondary trauma. They've used this particular measure that gets at a range. They take this survey and they end up calculating a total range. A score of 18 would indicate somebody who is very low secondary trauma. A score of 90 would indicate somebody who is a very high secondary trauma score. Okay, so that's helpful to know. And now let's work on interpreting, right? So now let's look at what's actually happening here. So we see officer PTSD symptoms reported by the spouse or partner. We see 0.45. So here's our little beta sign that we're looking for, and we see 0.45. And let's ignore the stuff we don't know. So we will learn about stars, and we will learn about confidence intervals later this semester. The stars indicate statistical significance, but that's not where we're at right now. So we're just going to focus on this value of 0.45. So essentially what this is saying is for every 1 unit increase in our X variable, in our independent variable, for every 1 unit increase in officer PTSD symptoms as reported by their spouse or partner, we would expect, based on this data, that the secondary trauma of that spouse and partner is going to also increase by 0.45 units. So it's a pretty small increase, but we can see that there's a positive relationship here. The more PTSD symptoms the spouse or partner perceives that the officer has, the more secondary trauma symptoms they themselves are going to be experiencing as well. All right, one example of one particular variable. Let's take a look at another one, and then we have a third if you want to hang on for the third one as well. So this article, let's take a look at what we're working with here before we dive in. This article is entitled Perceived Social Support and Mental Health Among First-Year College Students with Histories of Bullying Victimization. So again, we want to start with our thinking about what is the independent variable and what is the dependent variable. What is doing the influencing and what is dependent upon that influencing. So if we reading the heading of the table is always a great place to start. Linear regression analysis for variables associated with mental health in the fall. So we know we're predicting mental health. If we look at this chart a little bit more, we can see that there's 2 aspects of mental health they're predicting. They're predicting depression in the fall semester of when the study took place, and they're predicting anxiety in the fall semester of when this study took place. They also did some measures for the spring semester, but we're just going to look at this one. So they're predicting fall depression, fall anxiety for depression and anxiety for students in classes in the fall here. We are going to focus in on previous bullying victimization as just one of the predictors, just one of the possible influencers, the independent variables. We're going to look just at previous bullying victimization. So that's just going to be our focus. So that's going to be our X variable. Let's come back to that. Our Y variable is going to be those depression and anxiety scores. So we're using this particular variable. These are all the variables that are being used as independent variables predicting the impact on these dependent variables. We're just going to focus in on one. So that's what all these different levels are. We could look at how gender is influencing. We could look at ethnicity. We could look at college. We're going to focus just on this previous bullying victimization. How does that influence depression and anxiety scores? So first thing to know, this previous bullying victimization was calculated using this scale over here. It actually didn't include a range in their discussion, which sometimes happens with research articles. They don't always give us all the information we'd like to know. So we just know a little bit. They use the scale. Again, they treated this was an example of a construct. Previous bullying victimization was treated as a construct. So it wasn't just a question. They didn't just ask like, were you bullied? Yes or no. They included this questionnaire that assessed multiple aspects of the construct of previous bullying victimization. So they calculated that score somehow. Depression and anxiety were also, if you want to read about them, you're welcome to. We're also not given information about the range of these scores, so we don't know that, but they were also created using, so depression was assessed using the Patient Health Questionnaire 9. So another assessment tool was used to measure depression score. So there was some sort of overall score that everybody was given in terms of their depression rating. Same thing with anxiety. They were given an overall score to reflect their anxiety level. So these are the 3 scores we're working with. These are the 3 the 3 ratio interval level variables that we're looking at within this table here. Okay, so let's zoom in a little more. A complicated thing about this table is that we have B and then we also have beta. So they're both kind of the same as to what we've been talking about before. I had to do a little bit of digging to figure out which score we should look at specifically. Every researcher does these a little bit differently, which is not super helpful. Know that if you're being assessed on this information, I would be clear with you about what to focus on, or I would choose a table that was more straightforward than this one. For our examples, though, we're going to focus on the B score. So the beta score, this like fancy looking B over here, is representing something else, something slightly different. We're going to focus in on these scores. So these numbers right here, 1.61 as our slope amount. So what is this table showing us? It's showing us that a 1 unit increase in previous bullying victimization score, a 1 unit increase in our independent variable, leads to a 1.61 increase in both, actually. They got the same amount. So 1.61 increase in depression score and a 1.61 increase in anxiety score. So this is another example of the variables have a positive relationship. So they both increase together. The higher someone scored on that bully victimization scale, the higher their depression and anxiety was likely to be as well. So we're able to see how previous bullying and victimization can lead to an increase in depression and anxiety using this particular study. All right, let's take a look at one more. If you're feeling ready to hop off, feel free to hop off at this point. But I wanted to just include one more in case you're wanting a little bit more practice and exposure. You'll get a chance to practice this in your homework as well. This is a nice, slightly more simple version of a table, unlike the last one that we looked at. What we're seeing here is a study on social disadvantage and exposure to lower priced alcohol in off-premise outlets. We're just going to focus in on a couple things in this table as well. First, of course, we want to figure out what's being predicted here. What is the dependent variable that we are looking at here? If we read the heading, we can see multivariate linear regression model. So multivariate, we saw that term earlier. Here we see it coming back up again, especially in the world of regression. Things get very complicated very quickly. People end up throwing all kinds of variables all together. Still looking at linear regression though, so we'll do our best to focus in on just one of those variables. We're predicting the price of the cheapest 750 milliliter bottle of wine with adjustments for sample weights, other statistical stuff that we won't go into. So the independent variable we're going to focus on is the socioeconomic advantage variable here. Our dependent variable is price of wine. That's what we're predicting, right? We're predicting that based on the socioeconomic advantage, whatever that score was, however that was decided upon as a neighborhood characteristic. So when we look over here, we know that socioeconomic advantage is in reference to the neighborhood because we can see it's slightly tabbed under this neighborhood characteristics item here. So when we go up here and we see outlet characteristic, paces of alcohol shelves, chain, general license, drive-through, etc., all of these are aspects of outlet characteristics. These 4 items here are aspects of characteristics of adjacent outlets. And then these other items down here are aspects of neighborhood characteristics. So socioeconomic advantage falls under the category of neighborhood characteristics, meaning that they're talking about the socioeconomic advantage of the neighborhood itself, right? So just talking through how to interpret, how to read some of these charts. Here's actually their results where they tell us the same thing that we're going to conclude right now, but let's look at it first. So maybe this is a good chance to quiz yourself as well. How would you phrase the impact of socioeconomic advantage on the price of a bottle of wine? How would you phrase that? I'd encourage you to pause the video if you'd like to take a moment to think about that. So hopefully this is becoming a little bit more natural. Again, with this, regression can get really complicated, but if we break it down into the parts that we understand, we can get a feel for what's happening. So hopefully you are getting the sense that a 1 unit increase in socioeconomic advantage, it's going to have this impact on the price of wine, right? So and actually that's what they say over here too. A 1 unit increase in neighborhood socioeconomic advantage, and again, we'd have to look at the study to see exactly how they conceptualize that. A 1 unit increase in neighborhood socioeconomic advantage leads to an increase in the bottle of wine price by 0.02, which I assume is cents, right? Like, so 2 cents. So the more advantaged the neighborhood, the slightly higher price that bottle of wine is going to be. All right, that wraps it up for our brief dive into linear regression. Again, we're just getting a taste of that. It's a really interesting aspect of statistics. It is something that you will get to explore much more in depth if you continue to take statistical classes.